I wanted to quickly run through these solutions. I know our time's always short in class, and this is just the practice SAT, but maybe if you're looking at that tonight, you have an opportunity to see how some of these are answered as quickly and efficiently as you can do so, because, of course, on an SAT, we are limited on time. So let's go ahead and take a run through these. And, like number one here, as soon as you look at that and you go, oh my gosh, there's a graph. It says feeding of boarded pets, and the table shows, let's see, kinds of foods that are fed to cats and dogs boarded at the pet care facility. What fraction? Here's a key thing. The question, what fraction of dogs are fed only dry food? Well, dry food fed only is dogs. Okay. Here's the total of dogs. Total dogs is 25. So how many dogs are just fed, or what ratio? 2 out of every 25 are just fed dry dog food. Question 2, a simple distributing problem here. Okay. It doesn't say simplify, but that's what it means. Which one is equivalent to? So we're going to distribute that negative. Let's see if I can undo those erasers. There we go. We'll distribute that negative. So it's x squared minus 3. That's the stuff that was already there. And then as I distribute, I'll do it in red so you can see it, becomes positive 3x squared and negative 5. So now we just have to add like terms. There's our x squared terms. So that's 4x squareds. And then we've got some constant terms. Negative 3 take away 5. That's a total of negative 8. So it looks like answer A is our answer. Just straightforward solve thing. See here, we have a package that requires 3 centimeters of tape to be closed. How many packages then? So each package takes 3 centimeters. How many packages can we get from 6 meters? And they tell you a little conversion factor here. 1 meter is 100 centimeters. So if we have 6 meters, that's equivalent to, each one is 100, so that's 600 centimeters. And each time we make one, it takes 3 centimeters. So the question is, how many 3 centimeters are inside of 600? That's just a division problem. That comes out to 200. So if you did 200 packages at 3 centimeters apiece, that'd be a total of 600 centimeters you used. That's pretty straight. Question 4. We selected 200 people at random from a group of people who liked a book. So you got 200 people who like a book. Then the 200 were shown a movie based on this book and asked if they liked or disliked. 95% disliked it. So if 200 people, let's make some notes here. 200 people liked book. Of these 200 book, 95% not like the movie. And then it is, what can you conclude about this? Or what are these statements? At least 95% of the people who go see the movie will dislike the movie. No, that's not true. It's only 95% of the people who read the book. At least 95% who read books will dislike this movie. No, not read books, read this particular book. So it's not that one. Most people who dislike this book will like this movie. We have no idea about that because we only surveyed essentially 200 people who like the book. Most people who like this book will dislike this movie. That one's true. Okay, because 95% who liked the book didn't like the movie. 5. Which of the following order pairs make this satisfy or make this equation true? I would just test this by substitution. So like testing 1, 1, you replace the x in the equation up there with a 1 minus 3, and you replace the y with a 1 because that's the ordered pair they want us to check, 1, 1. And so that's 5 minus 3, that's 2. And so the question is 2 less than 4? Does it make it true? And the answer is yeah, that one makes it true. 2 is less than 4. Do the same thing with 2, 5. So it'd be 5, parentheses, but now we'd put in a 2 for x. minus 3 parenthesis, and we put in a 5 for y. And let's just check that out. Negative 5. Is negative 5 less than 4? Yeah, negative 5 is less than 4, so that certainly is true. And then we do it one more time, but we're testing 3 and 2. So 5 parenthesis, x is now 3, and y is 2. So I'm just substituting in and then seeing if it makes this true. That's 9. Is 9 less than 4? And that is false. So the two true ones are 1 and 2, and so it's just 1 and 2 only. Problem 6. We've got ourselves an equation here. A is a constant. That just means it's some number. And their question is, if x is 3, so when x is negative 3, it makes the equation true. It's a solution. What is a? So I know if I make x 3, so I'm just going to substitute in times negative 3 in there. So it's the same equation. I've just replaced the x value. And then I can clean this up. That's negative 3 times a. So this equation still has to be true. And this is a nice equation with only one unknown in it. We can solve this. In fact, we have solved just recently problems like this. We can square root both sides. And so we get negative 3a plus 3 equals, don't forget, it's plus or minus when you square root. So this is actually two equations we have to solve. The one where it could equal 6, and we have to solve the one where it could equal negative 6. So we'll subtract our 3 for this one on the left. Negative 3a equals 3 divided by negative 3. There's one possible answer. We'll subtract our 3 here. Negative 3a equals negative 9 divided by negative 3. We get 3. So a is either 3 or a is negative 1. Well, they don't give us the 3 as an option, so it must just be negative 1. Problem 10, based on the equation above, find the value of ax plus b. Look at this. We have ax and b right there. It's ax plus b. We got those 9s in front of it, though. So we got to get rid of the 9s. Just treat it like you're solving for ax plus b. So we'll slowly get this alone by adding 6 to both sides, giving us 27. And then to get rid of the 9s, we'll divide the left side by 9 and the right side by 9. So we just end up with ax plus b on the left, and 27 divided by 9 is 3. So ax plus b, which they wanted us to find, is 3. Easy enough. Problem 9, she spent 15% of her time in meetings, so 8 hours. How many minutes? They've even underlined it. So that's got to take it times 60 minutes for each hour. So it's 480 minutes each day that they're in at work, but in meetings, 15% of 480. That means multiply those two, and they'll tell you what percent or how many is 15%. Note how we changed it to a 0.15. 15% is 0.15 as a decimal. And if you carry that multiplication out, it comes out to 72. Software company. Let's see what this thing says. Software company is selling a new game in a standards edition, collector's edition. So we got two versions. The box for the standard edition volume is 20 cubic centimeters. So let's go standard. The volume equals 20 cubic centimeters. Collector's edition. His volume is 30 cubic centimeters, so it's a bigger box. They get 75 copies are asked for. 75 total copies of this game are asked for. The total volume is volume total 1,870 cubic. I've been doing cubic centimeters for these things. I should be doing cubic inches. Sorry, I'm used to the metric system. Makes a big difference, though, in terms of size. Let's see here. System of equations that can be used to write the total number or to write this. And they tell us S is the variable for standard, and C is the number of collector editions. Well, the first thing we're going to do is say, well, total number of copies. Okay, that means standard and collectors, so that's pretty easy. The number of standard copies plus the number of collectors' copies have to equal 75. Okay, now notice none of these answers have S plus C. None of them have that. But these first two are at least solved for C, so we can solve this one for C and then compare it to those. So we'll subtract our S. I get C equals 75 minus S. Or or if I rotate this, 75 minus S equals C. Well, that's these two right here. Now, the second equation must come from the volume of these two. Notice how the total volume is 1870. So they're adding up how much volume from each one. Well, if you sold S number of standard editions, let's say you sold one of those, and you took it times 20, it would tell you the volume because each one is 20. If S was 2, it'd be 2 times 20, 40 cubic inches. Okay, so this gives me the volume of the standard edition. This then will give you the volume of the collector's edition, C times 30. So I'm just going to say total volume for the standard plus total volume for the collectors has to equal total volume altogether. And that makes it clearly this first choice right here. Consumer paid $53 for a jacket after 6% sales tax. So let's let C equal cost of jacket. Not the $53. This is the cost of jacket with no tax. Okay. So the total price they pay for this jacket is the cost of the jacket plus 6% of the cost of the jacket. So 0.06 C. And that would give you the total price. So here's the price of the jacket. Here's the amount of tax, 6% of the cost. And that gives you the total you'd end up paying, $53. So we can solve this pretty quickly. That's 1C plus 0.06. So that's 1.06 C equals 53. And so to solve for C, we'll just divide by 1.06. And I don't know what that is off the top of my head. I'm going to grab my calculator here. You won't be able to see me get my calculator out, but I am going to now do 53 divided by 1.06. And it comes out to a nice even 50. C is equal to 50, and that'd be dollars. So there we go. Let's see here, 17. Get ourselves a pretty complicated looking graph here. Let's see what we got. And always identify, look, okay, so this is speed. Teresa's running speed, so this is speed versus time. So we can see she's speeding up, her speed's going up, then she stays at a steady speed, then her speed decreases, speed goes up, and then her speed comes back down. Now her speed is 0 again at the end. So this is on a treadmill. She's not going uphill. When these lines go up, it just means she's speeding up because that's what our y-axis measures. Her speed is increasing. So we're supposed to identify what is not true. Teresa ran at a constant speed for 5 minutes. Well, there's a constant speed. I just highlighted it in red because she's always going 7 miles per hour right there. You can see 7. Okay, and it didn't go up or down, so her speed is constant, and that's from 5 minutes to 10 minutes, so that is 5 minutes. 5 to 10, so yeah, that's true. Constant speed for 5 minutes. She increased for a longer period of time than she decreased. So I'm going to highlight increases in green here. Here's, oops, that's not green. Increasing there, increasing there. Let's figure out how long those intervals were. From 0 to 5. So there's 5 minutes of increasing. From 20 to 25. There's 5 minutes. So increasing speed, total 10 minutes. Let's do decreasing now. We'll do decreasing in kind of a grayish color. decreasing oh, that's not very gray. Decreasing here and decreasing here. Let's figure out the time intervals from 10 to 20. So there's 10 minutes. And then she was decreasing from 25 to 30, so there's 5 minutes. So she total decreased for the 10 plus 5 for 15 minutes. Teresa's speed was increasing for a longer period. Oh, that's not true. That one's false. Let's see if the others are true. Teresa's speed decreased at a constant rate during the last 5 minutes. Yep, it just kept going down, down, down at a constant rate. So that's true. Reached a maximum during the last 10 minutes. The last 10 minutes is down here, 20 to 30 minutes. That's her last 10 minutes, and she certainly did reach a maximum speed right there. She was all the way up to 8 miles per hour, so that one's true. So yeah, it's clearly only B, after we did our calculations, is not true. Polygons, interior angles. These are inside the polygon. These are all X. I'm going to give them 2 arcs to show they're all congruent. The formula for interior measure of a polygon that is convex is n minus 2 times 180, where n equals number of sides. Looks like hashtag number of sides. We got 4 sides, so it's 4 minus 2 times 180. 2 times 180, there's 360 degrees in this quadrilateral, 4 sides. The other way to remember it, and to me, because I always forget formulas, we got so many formulas out there, what you do is you just pick any angle, and you figure out how many triangles you could draw by connecting to another vertex. In this case, I can only connect to D. Any other line I drew from B would be just a side of the polygon. So I can actually break this polygon into 2 triangles, and each triangle has 180 in it. That's just by angle sum theorem in geometry, but all triangles have 180. So a 4-sided figure is made up of 2 triangles, and therefore we could calculate this 360 by saying, it's made up of 2 triangles. If you could make 3 triangles, it'd be 3 times 180. The point is, you need to know how many degrees are in the shape first. Okay, then we know what these all add up to, so we can just write 45 plus, we got 3 x's here we're adding together. All the angles have to add up to 360. Must subtract that 45 from both sides as I combine my x's together. That's 315, I think. So divide by 3. Looks like x, each angle must be 105 degrees. 14, 51-cent coins. So we got 50 coins. Give you 3 7/8 inches tall. So these coins are all stacked up, and if you pile up 50 of them, it would be that tall. It says, what happens if you ended up with how many coins if it's 8 inches tall? Well, we're just going to do a proportion here. 50 coins for 3 7/8 inch. Let's use the inch mark, is equal to X number of coins, let's use a C for coins, if it's 8 inches. So coins to inches. And then we just cross multiply here. So what's that? 450 times 8 equals 3 7/8 times C. Ugh. Now what we have to do is just divide both sides by 3 7/8. Now, if you're good with your calculator, you should be able to do that. If not, you may have to crank it out by hand. That's what I'm going to do. I'm going to make this a top-heavy fraction, or a improper. 3 times 8 is 24, and 24 plus 7 is 31. So this is 31/8 C. And now that it's that, I can multiply by the reciprocal on both sides. On the right-hand side, they cancel out, giving me just C. On the left-hand side, 8 times 400, that's 3,200 divided by 31. Think of that as being over 1. You just do top times top and bottom times bottom. And so now we just have to either get out a calculator to figure that out or do it in our head kind of. So 31 goes into 32 once, remainder 1, then 0, about 3 times. It's about approximately 103 times, so I'm getting 100 for that. Closest they wanted to, and 100 is clearly the closest. Okay, let's see here. Next question. Sorry, I was checking an email there. A minus b equals 12 and b over 2 equals 10. What is a plus b? I guess I'd figure out what maybe b is equal to. If I know b over 2 equals 10 times 2 times 2, I know b equals 20. So now I've got a minus b equals 12. That's the second equation, but I know what b is. B is 20. So a is, add 20 to both sides, 32. What is a plus b? Well, that's 20 plus 32. That's 52. So we can use the second equation here to find b. Now that we know b, we can find a. Then we can find a plus b. 18, we've got this equation here. This equation's not bad, except it's not in one of our standard forms, which is y equals mx plus b slope-intercept. So I'm going to rewrite this equation, 1.50x plus 19.99. So my slope is right there, and my y-intercept is right there. See, the equation miles total cost, so y tells me cost of dollars that a company charges a customer to rent a truck for 1 day and drive the truck X miles. So this calculates X, remember, is number of miles. So it must cost them $1.50 per mile. Total cost consists of a flat fee. That must be the 19. Okay, 19's the flat fee, because if you were to drive 0 miles, flat fee, not free. If you were to drive 0 miles, but you just had the truck and you were hanging out with the truck for some weird reason, they still charge you $19 or $19.99. So if X was 0, no miles driven, the cost would still be $19.99. So that must be their flat fee. What does the y-intercept of the graph represent? Well, that's our y-intercept. It represents the flat fee. It's not the charge per miles. That's what that $1.50 does. Somebody asked about this one in class, and I talked to them one-on-one because, first of all, what is a scatter plot? And what do they mean by a line of best fit? A scatter plot is just when you get a table of values, and you just graph them, just plot those points. In this case, they're graphing total income is like the X, and the Y value is percent spent on programs or charities. So that's your percent. So like an ordered pair here would be, I don't know, that's maybe like 1,175% they give to charity. And so each one of these dots, and this is what a scatter plot is when you just graph a bunch of ordered pairs. Now, if these ordered pairs make a nice pattern, awesome, but if they're scattered around, like these are kind of scattered around, what you draw in is a line that kind of is like an average of all these points. You can see as they had more income, their amount of giving tended to go up. Now, not all the time. Here's somebody who made over $4,000, and they were at 80% spent on these charitable programs. But as in a general rule, and this line indicates it, the more your income is, the more you ended up spending as a percent of your income. So that scatter plot and this average line they draw in, that's what we call that line of best fit. Just the best line we can do that kind of approximates what the data is doing. They want us to look at the which of the following is closest to the different asset and percent predicted by the line fit. Oh, I missed the beginning part. For the charity with the greatest percent of total expenses, I'm going to highlight him in pink. The greatest percent That's this guy right there in pink, because that's the highest percentage one, okay? And that's about, I don't know, 93% about. Okay, now the line of best fit predicts something different. The line of best fit at that same income level, about $3,500, the line of best fit says, we think they'll spend about 85%. So the line of best fit is clearly not in line with what they actually did. The question is, how far apart are these two things? And I've got 85 to 93, I've got them about 8% apart. That's not one of our options, but 7% is very close to that. We know it's not the 10% because clearly we can see this is 85 right here. It'd have to be way up here at 95 for it to be the 10%. So 7% is the closest to how far apart those 2 points are. A cylinder contains a piece of fruit and is filled to the top with syrup before it is canned or put the lid on. So this thing gets filled up with fruit. So they're going to put a bunch of fruit in here. But the fruit's not going to quite reach reach the top of the container. So then what they do is they just take a bunch of juice and top it off. So then they start filling it with juice in here until it reaches the top. And that juice, of course, sinks down inside between the fruit pieces. The question is, how much fruit did they put in there in terms of volume? Well, in this cylinder, you can look this up. This is on our formula sheet, but they tell you how to calculate the volume of a cylinder, and it is the area of the base times its height. Area base times height of the cylinder. They tell us the area of the base has an area of 75. The height of the can is 10 centimeters, so the total volume is area of the base times height, or 75 times 10. This whole container can hold 750 cubic centimeters. It's already got, or we're going to put in 110 of this blue liquid. So I'm going to start with 750. I'm going to take off the liquid I put in there, 110 cubic centimeters. That means the rest of it, the remaining part, 640, that's the fruit. So 640 cubic centimeters. 19, the function above miles height in feet after t seconds time. What does the number 72 represent? That's our constant. So when no time has gone by, t equals 0, the h of 0, it's at 72 feet. So that's its starting height before it's been launched, this object from the ground, because it's launched straight up in the air. So it must start at 72 feet, initial height. There it is. It's not the maximum height. As time goes on, it'll keep getting higher and higher, eventually coming back to the ground. ACT problems. Make sure you take that uh, 20 here. This is our last one, I think. Very last one. Let's find the slope of this line. Slope, remember, is change in y over change in x. Now, they only give us 1.36, but see the origin right there? That's another point. Okay, so the y over x is always going to be y minus 0 and x minus 0, because that's the other point we're using, 0, 0. So it really just comes out to the y over x value, or 6 over 3. The slope of this line is just 2, 2, 1, the y over x value. And it turns out that's just the y and the x value for any point, because you can always use 0, 0 as your second point. So if you give me the point st and I said calculate his slope, I would go the t value minus the y value of the other point. But remember, my other point I'm using is my origin. So t over s would be the slope, but the slope we already know is 2 over 1, so it's 2 to 1. No matter what point you pick, it's just y over x because the origin is our second point that we consistently use. And that should get you through a practice test. Turn that thing. All of the